Hi guys, it's Loren from D Squared Consulting. Today we are going to combine our discussion on heart valves and material properties. In the last video, Dory mentioned that when heart valves are not functioning properly, doctors may choose to replace them either by an animal valve or by an artificial man-made valve. Let's talk more about these artificial valves.
One of the most common artificial heart valves is the bileaflet valve. This valve is made of two semilunar or half-circle discs attached to a ring with hinges. These half-circle discs can lay flat and cover the blood vessel opening so the heart ventricle can fill. Or these discs can shift to create an opening in the valve to allow for the flow of blood. These discs also have a white mesh ring on the outside. This ring allows the doctors to stitch the valve into the vessel. This is important because surgeons can't exactly stitch into metal, so this white ring allows them to attach the artificial heart valve directly to the vessel. The metal leaflets and metal ring are typically made of pyrolytic carbon, stainless steel, or titanium, and the suture ring is typically made of polyester fabric. These are the typical stress strain diagrams for both titanium, which can be a material used to make the leaflets, and polyester fabric, which is used to make the suture ring. Let's take a closer look at the stress strain diagram for titanium. If you remember from the classroom video on material properties, this is a very standard curve for a metal. There is a noticeable linear elastic deformation region where the material is able to withstand a good amount of force and stress and go back to normal when the force and stress is no longer there. There is also a large curved plastic deformation region where the material begins to fail but is still able to function for a while until it completely fractures. Notice, too, how high on the stress axis the titanium is able to withstand, 550 to over 600 megapascals. Titanium is a very strong material. Strength is important when picking a material to make the leaflets because when this heart valve is functioning in the body, blood will be flowing fast through the valve. This causes the bileaflet valve to be subjected to a lot of force and stress from the flow of blood each time the heart beats. Now, let's take a closer look at the stress strain diagram for polyester fabric. This diagram, on the other hand, resembles a polymer. There is a very short, linear, elastic deformation region, but the majority of the region is curved. Look how far on the strain axis the graph goes. This means that polyester fabric is very flexible and stretchable. When we think about choosing a material for the suture ring, flexibility is important. The suture ring is being attached directly to the vessel and needs to be able to stretch and recoil with the natural blood vessel in order to function properly. Lastly, neither the titanium or the polyester fabric fractures without warning like a ceramic would. Think about it. When you are putting man-made material in the human body, wouldn't you want some warning that it is starting to fail and not function properly? It definitely would not be good if one day the valve just broke or cracked. People's lives would be at risk. So, in the field of engineering, material properties are thought about all the time. You can't make a successful product if you don't think about and choose the right materials. Thanks for tuning into this episode of D Squared Classroom.